Okay, domain and range. So domain and range are super duper, okay, important for us to understand simply because you will use them now, like for the rest of your math career, as long as that might be, okay? We're going to use it lots in this course in the next units coming up. We're definitely going to see it in grade 11, grade 12, doesn't matter if you do dash 1 or dash 2, okay? We are going to be using domain and range. So we are going to, like we've already talked about it a little bit. So you should be like, okay, I think I already know what domain and range is. We're just going to make sure we filter it through our math brains so that when you see some of the notations and when we're talking about things that you're totally cool with what we're doing, okay? So remember this, okay? And you can like write down, okay, in the margins, like write yourself some notes so that you will remember. So the domain, okay? The domain is always going to be your X values, your horizontal. Remember I told you, like, picture that you're the king or queen of your kingdom and you look out over the window over your domain. It's the horizontal part, okay? And then you decide that you want to get dressed for the day, so you're going to look at the temperature range. You're going to look at a thermometer that goes up and down. So the range is going to be your Y value, okay? I stress this simply because sometimes people get them mixed up. Okay, so domain is your X, is your horizontal, range is your Y, your vertical. Okay, now, okay, graphs with discrete values have points that are not connected. Remember, those were our individual dots. Those are discrete graphs. Okay, and for a discrete graph, we are going to, so let's go through some of our relations. We've got a whole bunch. We're going to identify what kind of relation it is, and then we're going to talk about its domain and range. Okay, so this type of relation, who can tell me what, like, how these are being presented to us? What are these called? When we have a bracket, a number, comma, another number, what's that called? Anybody? What do you think? It's an ordered pair. Okay, so this is just ordered pair. Okay, and when we do the domain and range for discrete values, we just list everything that they tell us. So in the domain, remember the domain is our x's. Okay, so I'm just going to shorten it up and say D for domain. And remember, we use our curly brackets. And we're just going to list 3, 5, negative 14, and 2. Right? That's our domain. Those are the numbers in our domain. The range, we're going to do the same thing. We're going to do an R for range. We're going to use our curly brackets. And we're going to list all the Y values, negative 10, negative 9, negative 5, and 15. Okay. So here's another example of a relation. Okay, we would call this one a graph. Okay, we could even say this one is a discrete graph. And it's discrete because it just has little dots. Okay. Now for this one, when we're doing the domain and range, you actually have to pull the X and Y values off of the graph for each dot. Okay, so what's the ordered pair for this dot right here? Okay, it looks like this is my x-axis. Right, this one's my y. Okay, looks like my scale is 1. So for every box, I'm going over 1. Okay, so this dot right here is going to be negative 4, 0. Everybody get that? Okay, so what I want for you to do is there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 dots. Okay, I want you to write down the domain. Okay, there's going to be 9 numbers in your domain, 1 for each of the X values. Okay, so you're just going over and you're going, this one's at -4, this one's at -3, this one's at -2, this one's at -1, this one's at 0, +1, +2, +3, +4. That's where the numbers come from. And then your range, you're going to do the same thing. You're going to tell me what each of the y values are. Now, question for you, is my range also going to have 9 values? Okay, it depends on the graph. Okay, in this graph, because there's repeats, right? There's 2 dots at y = 0. Do we need to write repeats in our domain or range? No, we don't have to write any repeats. Okay, so our range is going to be, okay, so here's our range. Now we're looking at the y values. This one's sitting at y = 0, y = 1, 2, 3, 4, and then it goes 3, 2, 1, 0. Okay, just make sure I got all of them. 1, 2, let's try the 2 again. 2, 3, 4. And then it goes back down. So remember, no repeats. All right. This next one, who would like to identify what this relation is? What is this next thing called? Yeah, or table of values. Okay. Excuse me for one moment. Okay, we're going to pull the x values from our table of values right here with no repeats. Okay, so go ahead and fill that out. And then you can check in with me. Okay, did you get 5, -3, 7, and 11? Okay, and then our range, you're going to do the same thing for the y values. Those are part of your range. There you go. So there weren't any repeats, so you should have 5 of those in your range. All right, up next. Hey, what's this one called? Yeah, Koji. Yeah. Right, and go ahead and write the domain. Remember, the first one is going to be our x values. The second one's going to be our y values. Okay, and domains and ranges don't always have to be numbers. They can be other things. Okay, we've done it where they're fruit. Oops. All right, our domain. Looks like maybe people's pets. With a cat, a dog, a snake, and a rabbit. And then our range, of course, is just the numbers and the y. Right, super easy, right, guys? Very cool. If only it would stay this easy, right? But then it wouldn't be grade 10 math. Okay, we got to build on this. Okay, we're setting down a nice foundation, making sure you understand. And then we're going to do some things with this. Oh, I think we might have one more. We do. We've got this little graph as well. Okay, this one is also, is this one discrete or continuous? Yeah. Can't fool you guys. Okay, see how you do with your ordered pairs, right? Finding the coordinates for each of the dots and putting those into your domain and range. I'm going to give you a second before I reveal what I have. How'd we do? Okay, I've got, do my x values, so I have -5, -3, -1, 0, 3, and 4. And the range Okay, I've got -3, -1, 0. Oh, I almost missed that 5 up there. 2 and 1. Okay, so I get them all. -1, 0, 1, 2, and 5. Okay, so can you see how sometimes, especially with discrete things, that trying to make sure that you have them all can be a little bit tricky if we don't write them in order. Okay, so it's not necessary, but how much handier would it have been if I had written these all in order, and then we knew exactly where each of the numbers should be in our set. So I'm going to encourage you, start practicing writing your sets in, like usually we start with the negatives, and then we go up to our positives. So write them in ascending order. Right. So here we go. Domain and range of graphs with continuous values. Okay, so this is where we do get to connect the dots. Okay, so again, graphs with continuous values are connected with the line. All values. So this is really important, this part here. Okay, all values on the line are part of the domain and range. Could you imagine trying to write like every single possibility in a list? Okay, you couldn't, right? Because like, say you were doing something like, okay, like a line like this. Okay, and if you had to write every single possibility, I mean, we've got some there, but then we have the in-between ones, and then we have like the really in-between ones. So you can see that mathematicians realized that we can't possibly write everything down, and so they created different ways for us to express what's happening when we have a continuous line. So we are going to use something called set notation to write our domain and range. Okay, we saw it a little bit yesterday. I kind of wrote a couple symbols, okay, on the board and explained, like, we're going to be using some Greek symbols like that E that doesn't look like an E, but it is an E, that epsilon. Okay, we're going to be doing some of that. Okay, so here we're going to explore number sets. Okay, we've kind of already talked about it, that remember how we had right, so just to remind ourselves, so this is a set, and each number inside is listed with a comma. Those are our elements. Okay, so when we're talking about number sets, that's kind of like what we're talking about. Okay, it can be represented on a number line. Okay, and what we're going to do is, if you turn over your page, you should have like a horizontal page in your notes. Okay, this is what we're going to be taking a look at. Okay, a closed circle. Okay, a closed circle indicates that we include the value. Okay, so we're actually, we're going to be looking at our number line, and here's mine. All right, so we're trying to take words, and we're going to just express them mathematically on a number line, and then using algebraic notation. Okay, so x equals 2. Okay, it's just a dot on 2. Okay, and how do we write that? We just write x is equal to 2. That's easy, okay? The math language is good there. All right, so if the value is included, we're going to do a closed circle. I'm just going to head back to our notes, okay? An open circle indicates that we don't include the value. It's excluded. Okay, what does that look like? Well, what happens here? The y values are greater than 1. Is 1 included? No, we have to be greater than 1. So that means that we go to 1 and we put a circle like where it is on the number line. Okay, so that's where we're like starting, but we're not including 1. So we do an open circle. Okay, and it says all the values have to be greater than. Am I going to draw an arrow to the left or to the right? Yeah. Okay, greater than 1 is in this direction. Okay, so that's what it looks like on a number line. Show me like if you've done number lines before. Okay, not new. Good. Okay, we do use them. Not a whole lot, but we do need to be able to read them and interpret them, and also put them into algebraic notation. So this means that I'm going to do y has to be greater than 1. Okay, when you were little, you probably learned your greater than and less than symbols. Like you put like maybe like little alligator teeth on it, and the alligator would like try to eat the larger number. Okay. In math, okay, we read from left to right, so we would read y is greater than. Okay, so this is a greater than symbol. So then let's do the opposite, okay? X values are less than -3. Okay, so decide, are you going to do an open circle or a closed circle? Awesome. Okay, you're going to do an open circle, and we want less than -3. So you're going to do your arrow going to the left. And then here, X has to be less than -3. Okay, so let's just make sure that we're getting our symbols and we're naming them correctly. When the symbol's facing in this direction, that's a less than symbol. All right, so if you're feeling like you got the knack of this, okay, or maybe this is already kind of what you've done, okay, go ahead and start filling in the rest of the chart on your own. Okay, if it's been a little while, then you can just keep pace with me. I'm going to walk through these examples. Okay, y values are less than or equal to. So when it has the or equal to, that means it's included. And the answer here is 0. So we're going to do a closed dot on the 0. And we want less than, okay, or equal to. So we want y values that are less than or equal to 0. Okay. Now I do it this way, where my equal sign is a little bit slanted. Okay, have any of you done it where the equal sign is straight? Okay, I'm okay with either. Okay, so when you see me write the symbol, you're going to notice that my line is just like it's just kind of tucks under the symbol. It means exactly the same as this. All right, so you draw it the way that you've been taught to draw it. I'm good with that. You might see it, okay, in the textbook, depending on just the font of the text. Okay, it might be either of those. Okay. All right, the next one, values are greater than or equal to -1. So -1's included. And as soon as they have an and, that means we've got boundaries. Okay, it has to be true for both of those. And it has to be less than or equal to 2. Okay, so it has to be greater than 1, but yet less than 2. So you just join up those dots. Okay, and when we do our set notation, okay, we always do the lower boundary first and then the upper boundary, right? Or the minimum and then the maximum. So the minimum here is -1, okay? And then we're going to, the symbols are, the dots tell us what symbols to use. Because they're closed dots, we're going to use the less than or equal to. Okay, we're going to put our, this one's a y question. Okay, and we're going to sandwich our y between the 2 dots. A sec. Y values are greater than or equal to and less than. Hey guys, you haven't written this down yet. No, this has to be greater than or equal to and less than 2. Okay, yes, I was still right. For a moment there, I panicked. I was like, I just drew the wrong symbols for everyone. And then I paused, okay, took a deep breath, okay, and came back to it. Okay, so the y values are less than 4. Okay, so we have an open dot on 4, and we've got to be less than 4. Y values are less than 4. Okay. X values are greater than -2. So we do -2 with an open dot, and we want greater than. And we're doing x has to be greater than -2. Okay, the x values are greater than -3 and less than -1. Okay, so again, now we've got boundaries on each side. So greater than -3, so an open dot because it's not or equal to, less than -1. Okay, so it's just between those two dots. And then we write the least value first. So the least value is our -3. And what symbol are we using? X. Okay, so this says x has to be greater than -3 and less than -2. So when we read this, okay, so when we're translating, I start in the middle and I say x, and then I read to the left. X has to be greater than -3, and then I read to the right. And x has to be less than 2. Okay, greater than -3, less than 2. -1, sorry. Thank you, there we go. That makes more sense. Okay, I was looking at the 2. That's why you have a pencil or an eraser or whiteout. Okay, we still call it, okay, this thing is like the greatest invention either, these little roller things. When I was in school, we had this little bottle that you'd have to shake and you'd unscrew it, and it was like nail polish. It would have a little paintbrush in it, and then you'd have to like paint over your mistake, and then you'd have to blow on it to let it dry, because if you tried writing on it before it was dry, you got a really big mess. Okay, so love this, way better than what I had. Okay, last couple here. Y values are greater than or equal to 0, closed dot, less than 3, open dot. Okay, join the dots. Okay, and we're going to say y has to be greater than or equal to 0, which has to be less than 3. Okay, do you notice that all of my symbols face the same direction? Okay, they're all like when we have boundaries, okay, they're all pointing towards the left. Okay, so it's important to recognize that that's what's going to happen. They're all going to face in the same way. You're not going to get one faced in one way and the other faced in a different way. Okay, so you kind of know that you're on the right path if all your symbols face the right way. And if you always do the lesser number on the left-hand side, right on the bottom, that's your lower boundary, and then your upper boundary, okay, then you just have to figure out, does it have an equal or equal to symbol or not? All right, and do I have one more up here? No. Okay, this one is for you guys. Oh, this was our introduction. Okay, I'm going to give you guys a few minutes. Okay, you have the worksheets here, domain and range worksheet. You have these already in your notes. Okay, this is what we're going to be doing. So if you need like a quick little stretch break, you can kind of get up, but we're staying in the room, but this is your movement break, and we're working on these 2 worksheets. I'm going to give us, I'm going to say about 10, 15 minutes, and then we're going to talk about the set notation. Okay? Yeah. Let's take a look at these. Okay, so check your work. Okay, this first one should be ordered pairs with the domain being 3, 5, -14, and 2. Okay, your range, -10, -9, -5, and 15. The next one is a discrete graph. We talked about this already. Okay, guys, you had to do a little bit of, I'm going to say guesstimating. Okay, just make a reasonable judgment on some of these dots. Okay, the time, there's no reasonability there. Okay, the time should be 3, 6, 9, 12, 15, 18, 21, 24, because they're on each of the axes. Okay, the range though, okay, some of the dots were like a little bit higher, a little bit lower. Here's what I came up with: 5, 12, 16, 18, 22, 11, and 6. Okay, if you were like, maybe you thought it was 12 versus 11, okay, I'm not too concerned. Okay, as long as you were like pretty close to this. All right. But as you can see, some of the graphs that you're going to be getting, especially the ones in your textbook, aren't necessarily going to be exactly where the grid lines meet. Sometimes they'll be a little bit above, which means your number needs to be a little bit above. Okay, and then the final one was also a discrete graph. This time I decided to practice putting things in order. Okay, I went from left to right, and so I found that all my x values were 1, 2, 3, 4, 5, 6. And then I went from the bottom and I went to the top. So I did -1, 0, 1, 2, 3, and 6. Okay, so if your order is slightly different, that's okay. Okay, as long as all the numbers are there in your range. But can you see how it kind of is a little bit easier to find the numbers when they're in order? Okay, so that's what I want you to start aiming for, is start tightening up things and kind of going towards ascending order. Okay, our number line, let me just fill this in real quick. The greater than -1. All right, x values are less than 2. Less than or equal to 3. And the x values are greater than -2. Less than or equal to 3. Close dot. Okay, so double check that last one. Make sure your symbols are all facing the right direction, that you have no more or no less of the or equals to's than you need. We always start with the smallest number on the left, that's our lower bound, and we end up with our upper bound. Okay, and we're just going to sandwich our variable right in between. Okay. So if you need a bit more time to write those in, I'm going to suggest that you head over to the podcast that'll be posted up in Google Classroom. You can just kind of fast forward till you get to that point, and then you can freeze the video and correct as we go. Okay, because I wanted to, this was the exciting part, wanted to talk to you about set notation. Okay, so for set notation, I'm sorry, I just have another page. There we go. Okay. Set notation is, there's a lot of graphs, okay, because we're going to be looking at graphs and seeing where the x values go and where the y values go, and just getting used to some notation. So I want you to like jot things down in the margins, right, to explain to yourself what things mean. Okay, so we've kind of already gone over this. We're going to be using curly brackets, okay, and we're going to be using this. Okay, this epsilon E, we were introduced to this. Okay, so it almost looks like a C with a line through it. Okay, so it's not like a regular E, it's an epsilon. Okay, and then this R, if the R looks a little different, okay, it depends on the type. You'll also see me write it with 2 bars going down for the R. Okay. So this, remember what this means? The E means belongs to. Okay, and the R stands for real numbers. So we will be using this mathy kind of notation whenever we're talking about continuous graphs. Okay. So what happens is we are going to have our general form of set notation is going to look like this. Okay, you can either write out the full word domain, okay, or you can use like a capital D to represent domain. Okay, personal preference. You can do whichever you like. You're going to see me do both. For right now, I'm just going to shorten it up and use D for domain. Okay, I'm going to open up my set with a curly bracket. And then I'm going to tell my audience, okay, I'm your audience, you are your own audience. You're going to tell your audience what variable we're talking about. So in what variable are we talking about when we're talking about domain? X or Y? X, awesome. So you're going to write an X. Okay, and then you're going to do a straight down bar. Like make it make it kind of big, okay? The bar, similarly to the epsilon, stands for something. Okay, the bar means such that. Okay, so I want you to write that in because you need to be able to know how to say that. So far I'm saying the domain X such that, okay, and then I'm going to tell you about the domain. Okay, so you're always going to list the variable first, and you're going to kind of like separate it with this bar. And the bar just, we read it as such that. Okay, and then what happens is I'm going to have, okay, some sort of restriction here, or like boundaries on where, like what happens with my domain. Okay, so in this part, I'm going to just have my, okay, we're not filling anything in specifically yet. I'm giving you like the general form. It's going to have some kind of restriction here, which we'll talk about in a second. After any kind of restrictions, then what you're going to see is you're going to have a comma, and then you're going to repeat your variable, and you're going to end with X belongs to real numbers. And then we're going to end our set notation with an end curly bracket. Okay, the range is going to be similar. The range, you can either use the whole word or you can do a capital R. You're going to have an open curly bracket. What variable do we use for range? Y. Awesome. You're going to do Y. You're going to do a such that. Right? You're going to do a bar. You're going to separate the variable from the restrictions. Okay, so same thing. So you're going to like, there's going to be something here if there are restrictions. Okay, after any restrictions, then we're going to do a comma, and we're going to do Y also, okay, belongs to real numbers. So Y, this little E, and then an R. Okay, so you'll always hear me say Y belongs to real numbers. You might hear your friend say, oh, do that YER thing, okay? But so what it stands for is belongs to real numbers. Okay. So now let's talk about, okay, this is why we just finished doing those number lines with the dots, open dot, closed dot, and what's in between, because we had boundaries, right? We had like the lower boundary came first, and then the upper boundary. So we're going to do the same thing. That's just going to fit nicely into our set notation. So let's take a look at example number 1. Okay, example number 1 is just a picture of a linear line, right? A straight line that has arrows on both ends, meaning that it will go on forever and ever and ever, okay? So when things go on forever, there are no restrictions, okay? So if it has no restrictions, this is what we're going to write. So our domain, X can be anything. It can be anything positive. It can be anything negative, okay? No restrictions. So our domain, we're going to do curly brackets, X such that, because there's no restrictions, we just go straight to the X belongs to real numbers. Like that. So X such that X belongs to real numbers. That's how we read it. That means that there's no restrictions. X could be anything. It can be negative 5,352. It can be positive 0.35. Okay, any number of X, no restrictions on it. Okay, how about our Y? Okay, here's our Y value. Okay, if, okay, given like a big enough X, okay, Y can be anything as well, right? Because there's arrows on it, it goes on forever and ever. We will eventually like get up to infinity over here on the positive side, and eventually we'll like go down to like really big negative numbers. Okay, so this example of a linear line with arrows on both ends means that there's no restrictions on the X and there's no restrictions on the Y. Okay, so in this case, we're going to write range y such that y belongs to real numbers. Okay, and then maybe write yourself a note here. This is what it looks like when there's no restrictions. Okay, on x or y. Okay, so this is what a domain and range can look like, right, when there's no restrictions. Okay, let's take a close look at B. Like, examine your paper. Tell me what the difference is between A and B. Yeah. Yeah. Is there an arrow on one side? Okay. So here we've got this line, okay, that ends. Okay, so we have to recognize that it ends here, but yet it goes on forever in the other direction. Okay, so that this means, so what you need to do is you need to like go down and figure out what that number is. What is that x value where our line ends? You can do that one for me. What's that x value? You think? -8. Yeah, I am in agreement. Okay, so this is, okay, x is equal to -8 there. Okay, while we're at it, why don't you like go over and tell me what the y value is? Yeah, I heard it. Y is equal to 6. Sorry, my pen just kind of went weird there. There. Y is equal to 6. Okay, so we need to know. So you could either write it like this, like where I've kind of gone down, or if you're good to write it as an ordered pair, this would be -8, comma 6, right? That's the dot that we're looking at. Okay, so this is really the only restriction. The graph does not exist, okay, anything less than -8. Can you see that? The graph like only starts at -8 and then goes on. Okay, the graph does not exist up here. The graph exists from 6 and anything down below. Okay, so this is an example where we are going to, okay, our domain for this one, here, I'm going to write it over here. Okay, x such that, okay, x has to be, does x have to be greater than or less than -8? What do you think? Okay, well, I've got one of each. Okay, so less than -8 is over here. Does my graph exist over here? No. Greater than is over here. Does my graph exist over here? Yeah, there's an arrow over here. Okay. Do I have a closed dot or an open dot? Closed dot. So I'm going to do, okay, I'm going to say that x has to be greater than or equal to -8. Are there any other restrictions other than that one? It just has to be greater than -8. Okay. So this is my restriction, and then I'm going to do a comma. Other than that, though, x belongs to real numbers. Okay, so there's kind of 3 parts in your curly brackets. There's stating the variable that we're talking about with the bar. Then if there's any restrictions, you're going to put those in, and you're always going to end with x belongs to real numbers. Okay, with restrictions, without restrictions, it always has this x belongs to real numbers. Okay, so my range is, okay, I have to only exist less than 6. Okay, so let's mathify that, put it into set notation language. Let me raise this up a little bit here. I still want to see my graph. There we go. So y such that y has to be less than or equal to 6. After that, y belongs to real numbers. Okay, are you seeing how this works? Yes. Okay, C. C is a line segment. It has closed dots on each end. So that means that it doesn't go on forever. It definitely has boundaries. It can only go from this point to this point. Okay, and from this point, this y value here, to this y value here. Okay, so let's first identify what our ordered pairs are for these dots. Okay, so go ahead and look on your graph and tell me what the ordered pair is. Like, write it down on your sheet, count it out, make sure we can accurately. Do I even want to ask? No, I don't. Gotcha. Okay. All right, so here we go. Hey, did you get -4, -8 as your one coordinate? And this one is +7 and +8. Did you get those values? Okay. So when we're dealing with our domain, we're going to be looking at the x values. Okay, so the way that we've written it, right, we've just showed you where your two limits are for your x. It has to be between -4 and 7. So your domain, x, such that you always write the lower limit first. So your lower limit is -4. Okay, we're going to sandwich our x in between them. And then we're going to do our upper limit, which is 7. We're going to do our comma. Sorry, I'll put the comma down a little bit. And then x belongs to real numbers. Okay. See how these two numbers match the coordinates, the x's on your coordinates for your ordered pairs for the 2 points here. Okay, and then we're going to do the same thing for our y. We're going to pull from the ordered pair, we're going to pull our two boundaries. And we're going to say that our range y such that, okay, we have to be between -8. We're going to sandwich the y this time in between them, and we can go all the way up to +8. And y belongs to real numbers is how we always end it. Okay. My E looked a little bit too much like a T there. Okay, we're going to do one more example. Okay, and then I will leave the rest for tomorrow. Hey, guys, who remembers what the shape of this line is called? Yeah, this one's the parabola. Okay, the one that looks like, hey, put it away if you're on your phone. Okay. Okay, parabola is the U-shaped one. Hey guys, parabolas are a little bit special because look at this. It has a point, it's like it kind of got down to this point and then changed its mind and it went back up again. Does my graph exist in any of the -y values? No. Okay, so here, this point right here, 0, 0, okay, the y value, okay, that's our minimum point, and then it's always got to be above my minimum point. Okay, take a look at my x's. Okay, they have arrows on the end, which means that this graph can go on forever. Is there a restriction on my x values? No, there's not. Okay, awesome. Okay, so if there's no restriction on my x values, then we can write our domain. Here's, remember how you write it when there's no restrictions, x such that x belongs to real numbers. So we can remind ourselves, no restrictions on x. right? Because it has arrows. And then our range, parabolas will always have a restriction in the range, right? Because they've got this maximum point or they've got a minimum point. And so it doesn't exist beyond that. So all you need to do is get the ordered pair for that max or the min and look at your y value, okay? And decide, does it have to be greater than or less than 0? Okay, for us, we have to be greater than or equal to 0. Okay, so if your graph is above 0, it's got to be greater than 0. If my graph was downward facing, okay, then it would be less than 0. But it's always got to exist. It can exist at 0 and anything above it.